Hi, Calculus Unit 5, Day 43 notes. Our objective is to learn and apply the basic ideas of average velocity, average acceleration, instantaneous velocity, instantaneous acceleration of motion, and how they relate to calculus. We will learn and apply the 5 commandments of particle motion. Okay, so particle motion problems deal with particles that are moving along the x or y axis. So we're speaking of horizontal and vertical movement. The position, velocity, or acceleration of a particle's motion are defined by functions, but the particle does not move along the graph of the function. It moves along an axis. So most of the time, we're going to speak of movement along the x-axis. In Unit 6 and 7, particle motion is revisited. At that time, we'll deal with more with vertical motion. For the time now, we're going to focus on horizontal motion of particles. So in this lesson, we're going to develop the ideas of velocity and acceleration in terms of position. We will speak of 2 types of velocities and acceleration. So let's define average and instantaneous velocity down below. Okay, so we're going to look at the average and instantaneous velocity, which is the rate of change in position. So the average velocity on an interval from A to B is equal to P of A minus P of B all over A minus B. And again, P of A represents the y value when x is A, and P of B is the y value when x is B. So this is change in y over change in x, or rise over run. So we should know what that is, slope between 2 points. And where P of t is the position. Now I also wrote S of t. S of t is not speed. It stands for position function. Some books and some examples we're going to use, and books you'll see later on, a lot of times S of t is used for position, and that can be confusing because we think of S as speed. Okay, but P of t for right now is what we're looking at as position, and then instantaneous velocity is equal to the derivative at some given point. So um, so what I want us to start thinking about, and we'll talk about this more later on, this is slope of the secant line for the average velocity, and this is slope of the tangent line for the instantaneous velocity. Okay, so let's look at an example of this. Particle's position is given by the function P of t equals E of t times sine t, right here, where P of t is measured in centimeters. Again, P of t is the position function, and t is measured in seconds, so for time. Answer the following questions. What is the average velocity? Okay, so I'm looking for the slope of the secant line. On this interval, t equals 1 to t equals 3. So I now know, hey, average velocity is going to be equal to P of 1 minus P of 3, and it doesn't matter if I switch those around, but if I go P of 1 minus P of 3, then I have to go 1 minus 3. So every place I see a t, I'm going to put in 1. So e to the first times sine t, and then we're going to subtract P of 3. Again, you can use your calculator for that, and we'll end up getting negative 0.547 over negative 2, and this ends up being 0.274, and this is centimeters per second. Okay, and that's rate of change. All right, let's go to the next example where we're trying to find the instantaneous velocity. So, I gotta slide this down, sorry. What is the instantaneous velocity of the particle at time t equals 5? Well, let's look up above. When we talk about instantaneous velocity, we are talking about slope of the tangent line. So let's do that. So in order to find slope of the tangent line, I have to take the derivative. And so we got p prime of t, and let's, oh, there's our function right there. We have to use the product rule. So we'll do derivative e of t is e of t times 1, leave the sine t alone, plus the first stays the same, and then the derivative of sine is cosine. Um, so we don't need the, let me just rewrite that without the 1. Okay, so just rewrite it, and now we're trying to find the instantaneous velocity. That's the derivative, so every place we see a t, we're going to substitute in 1.5. e of 1.5 times sine of 1.5 plus e to the 1.5 times cosine of 1.5. Let's just put that in our calculator, and we're going to get 4.787, once again, centimeters per second. So at 1.5 seconds, that's our instantaneous velocity. Okay?